In this lecture, we'll finally show how we can actually implement our training, validation, and test pipeline in Python. So hopefully that brings a lot of the ideas we've seen previously in these more theoretical lectures into clearer view, and we will make it clearer how we can actually select our regularization parameters and evaluate our model performance using a validation set. Okay, so just summarizing what we've shown so far when we're building a validation pipeline, our goal is going to be the following. We're going to split the data into training, validation, and test portions. We're going to consider several different values of our hyperparameters, for example, just lambda. For each of these values, we'll train a model on the training set. We'll evaluate that model's performance on the validation set. And whichever model performs best on the validation set, we'll compute its performance on the test set. Okay, so how does that look? Okay, so how does that look with some code? So first, we're going to set up the prediction problem. All of this is code we've shown before. We're just reading in our Amazon gift card data. We're converting all of the numerical values to integers. And next, we're going to extract some features. Again, this is the same as previous code. All we're doing is removing punctuation, removing capitalization, tokenizing our reviews, and then taking the 1,000 most common words to build our 1001 dimensional feature representation, which also includes an offset term. But nothing new there. And you can look back through the lecture where we developed this code to see this in more detail. Okay, first thing we have to do is to split our data into training, validation, and test samples. First thing which is important is to shuffle the data first. What we required is that our training, validation, and test sets should be independent and identically distributed, or just non-overlapping random samples of the data. So shuffling the data set is an easy way to ensure that that's the case. Next, we split the data. Okay, so I build xtrain, xvalid, xtest, ytrain, yvalid, ytest for my training, validation, and test sets. In this case, I split them such that the first 50% of my shuffle data is in the training set, the next 25% in the validation set, and the final 25% in the test set. And those should be non-overlapping splits. Of course, you should try other ratios, and later on I'll give some guidelines for how you might do this. Okay, so in terms of actually fitting the model, again, we're going to use the ridge model from sklearn. So reminding ourselves what this does, this is just regular old linear least squares regression like we've been doing since the very beginning of this course, but it also includes an L2 regularization component. So it's just trading off the mean squared error versus the model's complexity. And it's trading them off using this value or this parameter called alpha, which is exactly equivalent to what I've shown as lambda in the equations. Okay, next thing we need is a quick utility function. This is just a function to calculate the MSE for a particular model. So we will pass a model into this function, which really corresponds to a set of theta values that we've trained for a particular value of lambda. We also pass it some sample of the data x and some sample of the labels y. So this could be our training set, our validation set, or our test set. And then all it does is it makes some predictions on x using the model. It computes the differences between those predictions and the label that's given, and returns the mean squared error. Okay, and this is really the code that corresponds to our training and validation pipeline. So we're going to train the model for a bunch of different regularization parameters. The first thing we do is just keep track of which model has actually worked the best as we're going to go along. And then as we iterate through the different values of lambda, in this case by powers of 10, we just fit a model for each lambda value. And as we do so, we're going to report the training and validation error. Note that we don't look at the test set at all yet. And finally, we are going to keep track, in the bottom 3 lines of this code, of which model is working the best. So if the validation error is lower than the best validation error we've seen so far, we will store that model as our best model, and we will store its best performance for comparison later on. And we're just printing out the results as we go. Okay, so once that validation pipeline has finished, once we've iterated through all values of lambda, we should know which model worked best on the validation set. That's going to be stored in the variable here called best model. So we can compute its test error for the model that worked best on the validation set, and this code just prints that out. Okay, so that's about it. Hopefully this brings things into much clearer view. So all we did here was showed a full pipeline of model selection and evaluation on a real data set. So I would suggest on your own, trying to reproduce this pipeline for a different task, possibly for a classification versus a regression experiment.